Okay, so we've just done our experiment. What did we observe?
The cold water did nothing.
The cold water did nothing? Okay, awesome. What about its state? We learned last lesson about changes in state. How would you describe the changes that we've seen?
It got soft in the hot water.
Yeah, so we could say that the heat transferred from the boiling water to the beeswax, and as a result, our beeswax actually got a lot softer. And if we had left that beeswax in that boiling water, eventually that beeswax would have turned into a liquid. And we actually noticed that when we returned our beeswax to the cold water, it went hard again. So it became more of a solid. And if we had have added hot water again, it would start to melt again. So this change of state is actually reversible. And Aboriginal and Torres Strait Islander peoples have long understood that applying or removing heat to certain materials can deliberately cause changes that they can use for specific purposes. They knew that the heat softens certain substances, making them what's called malleable. Now, malleable means like squishy, it means you can change its shape, and it's kind of a bit like Play-Doh. Now, when you remove the heat from these substances, it results in the materials cooling and it begins to harden back into its solid state. And this is actually known as having thermoplastic properties. Now, we've seen this firsthand because we watched this happen with the resin and the beeswax that we just experimented with. And these are examples of thermoplastic materials. And different Indigenous groups across Australia have used these materials in unique ways based on what local plants and what local bees were native to them. So as you can see on the side here, there's this cool image. This is some spears from North Queensland. And we're going to see in a minute just how they used beeswax and resin for these cool spears. So, as you can see in this little corner up here that's highlighted in red, the Wimmera peoples of the Western Cape York Peninsula region in Queensland used to fire beeswax to heat it, change its state, get it nice and malleable, and they would actually use it to repair cracked water carriers and also to attach decorative clothing. And that's because when they removed the heat and let it cool, the wax would harden again into a solid state, extending the durability of their cracked water carriers and also acting as a glue. The Turrbal peoples of the Brisbane region, which is highlighted in this maroon area, would use beeswax by again holding it to a flame, causing it to change its state. They would actually get it from a solid to a liquid, which we didn't do today, but if we left it in the water long enough, that's what would happen. And they would actually rub it all over their shields, and they would do this because, again, when the beeswax would again harden, it would become nice and sturdy and hard and act as a preservative. Now, they are still using beeswax in this region. They use it to attach stingray barbs to spears, fix handles to axes, and also waterproof vessels. This is just a little diagram of what we've just discussed. The heat is applied, it transfers to the beeswax, it becomes a soft and sticky, malleable product. Again, if you leave it long enough, it will completely turn to a liquid. And then when it's cooled, it becomes solid again, so nice and sturdy. So to summarise, for thousands of years, the Aboriginal and Torres Strait Islander people have heated resins and beeswax to change its state. It was used as an adhesive for decorations and tools. It was also used to act as a glue to bind spear points and stone tool handles. And both resin and beeswax are actually waterproof as well. So again, they acted as a protective barrier. So I'm going to get you guys to head back to your desks now, or you can find a quiet place on the floor. Get your investigation folio workbooks, and you're going to do this activity. The activity says First Nations Australians heated beeswax to attach stone blades to wooden spear handles. When the beeswax cooled, the blade stayed firmly attached. Explain why heating and cooling the beeswax was important for making these tools work.